Question 1 on AQ A-Level Chemistry, June 28th of June, Monday 8th of June 2020, paper 2. This question is about rates of reaction. Phosphonate ions react with hydroxide ions to produce hydrogen gas, as shown. Then it says, use the graph 1.1 and figure 1 to determine the initial rate of reaction for this experiment. State its units. So its units is going to be this and this. So it's going to be centimeters cubed s to the power minus 1, because that's what we're dividing, right? Centimeters cubed divided by s, so centimeters cubed s to the power minus 1. To determine the initial rate of reaction. So the initial rate of reaction is when it's going to be here, right? So what we need to do is we need a tangent drawn to the curve at 0, 0. Obviously I don't have a ruler on here, but it should be a straight line. Tangent drawn to the curve at 0, 0, and then we can pick 2 points. So I'll pick this point and this point, and you know that triangle idea. And to find out the gradient, y2 minus y1 over x2 minus x1, y2 100 minus 50. This is always y2. Further to right, this is y1. So 100 minus 50 over 20 minus 10 over 20 minus 10, which will give me 50 over 10, which is equal to 5. That's the gradient, and then for the rate, which is a change in concentration divided by time, it's going to be 5. And it says in the mark scheme, allow 5 to 7, and the centimeters cubed s to the power minus 1 is the units. 1.2, state the relationship between the initial concentration of phosphonate ions, of phosphonate, and time. Well, we can see that as the initial H2PO2 minus increases, time in seconds decreases. That's a clear observation, you can see. So, what can we really say? So they are inversely proportional, but what we can say is 1 over time. So H2PO2 minus is proportional to 1 over T. Because it's inversely proportional to T, it's going to be proportional to 1 over T. And then it wants me to determine the order of reaction with respect to phosphonate. So let's look here. Okay, 0.25 to 0.35. What's the difference between those? 0.35 divided by 0.25. Timesing by 7 over 5. Over 5, right? If we do 0.25 times by 7 over 5, we get 0.35. 32 divided by 64, we times in by a half. We're dividing by 2. Yeah, we'll say dividing by 2. Actually, let's use 0.25 and 1.00. So here, how do we get from 0.25 to 1.00? We times by 4. How do we get from 64 to 4? Well, we're dividing by 8. No. 64 divided by 4, we're dividing by 16. 16. So basically, what we need is we need these two, 16 and 4, to be the same, right? So Therefore, this must be squared because it will give me 16 squared, and then 16 squared divided by 16. So therefore, because the rate of reaction increases by 16, because we're dividing by 16, so 1 over T increased by 16, so should H2PO2 minus. And the only way for it to increase by 16 is if it's squared. So the order must be equal to 2, and therefore it's going to be H2PO2 minus squared is proportional to 1 over T. 1.3, 1.4, 1.5, 1.6, 1.3, complete the diagram in figure 2. So, show how hydrogen gas could be collected. So we've got the reaction mixture. We've got this. Well, what is this piece of equipment called? It's called a conical flask. Conical flask. Reaction mixture, conical flask, and then the gas syringe. So it should look something like that, right? And then label it gas syringe. 1.4. Reduce the overall effective rate of reaction with the concentration of both L and M a half. Well, let's look at it. If L and M are halved, we're going to have a half times by a half L times by a half M squared. What do we get? Well, a half times by a half squared, we get an eighth. So the overall rate of reaction, well, we're going to multiply it by 1 over 8. So it's going to be multiplied by 1 over 8. And that's the way I would do it. And then 1.5, the rate of reaction is this when the concentration is that. Calculate concentration of M if the rate constant. Remember, rate constant is equal to K. So I feel like they purposely wrote rate constant to trick students out, because if they labeled it K quite clearly, it'd be, I think, a lot easier. So we know the rate equation is this. Rate is equal to KLM squared. So let's write that down. Rate is equal to KLM squared. What are we trying to find? We're trying to find M. So we need to make M the subject of the formula or of the equation. So we get M squared is equal to rate divided by K times by L. And we've got rate. We know rate of reaction is 0.0250. And in this question, it already gives us the units, mole per dm minus cube. We don't need to worry about the units. Over K, which is rate constant, which is 21.3, times by L, concentration of L, 0.0155. Now this won't give us the answer. This will give us M squared. So therefore, to find M, we just need to square root this whole thing. Which in the exam I'd write it all down, but it's just a waste of time since I'm drawing on a mouse. 0.0250 divided by 21.3 times by 0.0155, and then just press square root my answer, and I get 0.275 mole per dm minus cubed. And then 1.6, define the term overall order of reaction. Overall order of reaction is the sum of powers to which the concentrations are raised in the rate equation. Overall order reaction, sum of powers to which the concentrations are raised to in the rate equation. And that is the end of question 1.